Today's lesson is on multiplying rational expressions. Now the good news is you can multiply rational expressions if you can do two things. If you can multiply numbers and variables and simplify a rational expression, which is what we did earlier on the previous video. If you can do those two things, you can multiply rational expressions. We've got 4 simple steps. We first have to find our restrictions. Now, restrictions we talked a little bit about before we started on our practice. Restrictions are where the denominator of our rational expression equals 0. You can also find that restriction by looking at your graph of your rational equation, and where there's a gap, or what we call an asymptote, that is a restriction. Then we are going to simplify anything we can. Now what you're going to find is you can do the simplifying on the front, you can wait and do all of it at the end, or you can do some on the front, then multiply, and then finish simplifying at the end. It's completely up to you. Then we're going to multiply our numerators straight across, then we are going to multiply our denominators straight across, and then if we can, we will finish simplifying anything that's there. So let's go ahead and do an example. Okay, we're going to start off multiplying 8a times 11 over 12a. Now, anytime you have a whole number, whether it's the first term or the second term, let's always put a 1 under that whole number. Okay, it's just going to make things a little bit easier for us to see. All right, we need to find our restrictions. Now, I'm going to take or look at my numerators. I have an a, or a variable, in this one, so I'm going to do 12a equals 0, and then I'm going to solve for a. So divide both sides by 12. So a equals 0. What that tells me is if I plug 0 in here, 12 times 0 is going to be 0. We can't have that. So my restriction is going to be at a equals 0. Again, you can also type that into your calculator and see that there is an asymptote, or a hole, at x equals 0. Okay, now I am going to simplify anything I can. Now I notice that I have an a up here, and I also have an a down here. We are only going to cancel top to bottom. Remember, when we say cancel, we really mean divide. So a divided by a is 1. That's what makes it go away. Okay? Now, I also notice that my 8 is divisible in the numerator is divisible by 4, and my 12 in my denominator is divisible by 4. So I'm going to go ahead in a different color. 8 divided by 4 is 2, and 12 divided by 4 is 3. Okay, so I've done any simplification that I can see. Now I'm going to multiply my numerator. So I'm going to go straight across. Well, my numerator here is actually 2, and 2 times 11 is 22. Down here I have a 1 times this 12a became just a 3. So 1 times 3 is 3. I can't reduce that any further, so this is my final answer. Easy enough. Okay, let's do another example. Okay, here we have x plus 3 over 4 times 3 times x minus 6 times 3 times x plus 3. So the first thing we're going to do is find our restrictions. To do that, I'm going to take my denominator. There's no variable here with the 4. There's no variable here with the 3. But I do have a x plus 3 right here, and I'm going to set it equal to 0. So anywhere there's a variable, we want to set that expression equal to 0. So I'm going to solve for x, subtract 3 from both sides. X equals negative 3. So what this tells me is that x can't equal negative 3, because negative 3 plus 3 is 0, and 0 times 3 is 0, and that would leave a 0 in my denominator. Again, you can plug this fraction into the calculator, and you are going to see that at x equals -3, there is an asymptote, or a hole. Okay, let's go ahead now and multiply. So our next step after restrictions is to simplify. Well, I'm going to go ahead and put parentheses around this. Now I notice I have an x plus 3 on top, and I have an x plus 3 on bottom. Now notice I'm treating that as a single term. I can't just cancel these two 3's because this 3 has a plus in front of it, and we've talked a little bit about that. So let me erase that. So I am going to cancel this x plus 3 with that. X plus 3 divided by x plus 3 is 1. So that's a 1 up here. Now I also notice that I have a 3 here and a 3 here. So I can cancel those, or divide. 3 divided by 3 is 1. All right, that's all I see that I can cancel at the moment. So I'm going to go ahead and come down here. I am going to multiply straight across. So 1 times x minus 3, x minus 6 is x minus 6. And 4 times, there's an understood 1 here because we were able to divide all that out, so that's just 4. I cannot simplify anything else, so this is my final answer. Okay, let's do another example. If you feel like you're good, you can stop and move on, but we're going to go ahead and do 2 more examples. This one is going to be very similar to what we just did. Okay, the biggest difference between this one and the last one is that the last one we already had a GCF factored out, this one we don't. So the first thing I need to do is find restrictions. So I have a variable in both of my denominators, so I'm going to need to do both of them, set both of them equal to 0. Darn it, sorry. Minus 4 equals 0, so I'm going to add 4 to both sides. So b cannot equal a positive 4, but now I also need to do it for b plus 10. So b plus 10 equals 0. Subtract 10 from both sides, and I get b equals -10. So my restrictions are b cannot equal 4 and b cannot equal -10. Again, you can check that on your calculator. Now, I notice that this numerator has a GCF. It has a GCF of 7. So I'm going to factor a 7. 28 divided by 7 is 4. -7b divided by 7 is -b. All over b minus 4, and then 1 over b plus 10. All right, now what I'm seeing here is that these two look very similar, but the signs are not in the right spot. So what I'm going to do is I am going to factor out a -1 from the top. So negative, well, my pen doesn't want to write now. Okay, so if I divide -7 or +7 by -1, I get a -7. If I divide this 4 by a -1, I get a -4, and I'm going to move that position. If I divide this -b by a -1, negative and a negative make a positive. If you notice, I just made the top look like the bottom. That's all I was doing there, okay? And times 1 over b plus 10. Okay. I notice that I have a b minus 4 and a b minus 4 on top and bottom. So those can cancel each other out. B minus 4 divided by b minus 4 is 1. And then I'm going to multiply straight across. -7 times 1 is -7. And 1 times b plus 10 is b plus 10. Okay, we're going to do one last example. I'm going to give you a second to try it on your own, and then you can check the answer. Okay, here's your problem. I want you to find the restrictions, hit pause and find the restrictions, come back and check it, and then hit pause again and try working it, come back and check it. Now what you might notice here is we actually need to factor this denominator before we find the restrictions. So if you use your calculator, put that denominator, x squared minus 2x minus 6, in there, you're going to find that your factors are -3 and +2. Now find your restrictions. So here are your restrictions. X cannot equal -3, x cannot equal +3, and x cannot equal -2. Hopefully you see now why we needed to factor that first. It just makes it easier to find the restrictions. Okay, hit pause again, solve it, and check your answer when you're ready. Now hopefully what you realized was that we needed to factor x squared minus 9 into x plus 3 times x minus 3. And then at this point, we could divide this x minus 3 by that x minus 3. It has to go top to bottom. It cannot go side to side. And then we can cancel this x plus 3 with this x plus 3. So your final answer should be x minus 3 over x plus 2. All right. Good luck. Come back and look at them if you need to.